So today we will cover 6.4, the law of signs, and the ambiguous case. We will come back to 6.3, part 1 and part 2 after we finish 6.4 and 6.5. So the law of signs is a simple concept. You take the formulas and proportions is sine of capital A, which is the angle, over little a the side equals sine of capital B over little b equals sine of capital C over little c. What that simply says is that the sine of that particular angle over its corresponding side is equivalent to the ratio of the side of another angle in its corresponding side. So three types of triangles that we look at when we're dealing with the law of sine is angle side angle, angle side, and side side angle. Notice that angle side angle, you have an angle and the side is between the two angles. Angle side, angle, then a side. The side is not between. And then you have side angle. All right, so we want to know how to use the law of sine to find missing side or missing angles. And we know we round everything to 3 decimal places. So this type of triangle is angle, side, angle. So we can use the law of sine. So we're going to find side A. So that would be this corresponding side here. So we just set up the ratio. Sine of capital A, which is 76, over little a, equals sine of, we can't use 60 because we don't have 60's corresponding side, but we can use angle B. Well, if we want to know what angle B is, all we have to do is add 60 plus 76 and subtract it from 180. And that gives us 44 degrees. So we'll do sine of 44 over 20. So that gives us the proper ratio. So remember, if you are going to use an angle, you have to have its corresponding side in order to use it. So that's why we found angle B, which is 44, rather than using angle C, because we didn't have little c, but we did have little b. And remember that corresponding side is always opposite of that angle measurement. So now that we have all our information that we need to find this, we're going to cross multiply. So we'll do 20 sine 76 equals a sine of 44. Cross multiply. And then we'll divide by sine of 44. So a equals. Now I'm going to put this in the calculator. Remember to use your fraction bar. And that gives us 27.936. It's our side length. All right, moving on to the next one. Pay attention to your answers. Make sure it makes sense. Since angle A is the largest angle, that means little a has to be the largest side. And being that it's 27, that would make sense for it to be the largest side. Next, we'll move on to B. So this one says to find angle B. So we know we have to set up the sine of B over little b, which is 27, equals sine of C, 69, over 30. Again, we're going to cross multiply. But in this case, cross multiplication is not necessary since you're solving for something that's already in the numerator. So we're just going to multiply both sides by 27. And that gives us sine of B equals 27 sine 69 over 30. Notice I don't put anything in the calculator to the very end of the problem. Remember, since we're trying to find an angle measurement, we're going to use an inverse trig operation. Anytime you're trying to find an angle, you use an inverse trig. So we're going to do the sine inverse of both sides, and that gives me B equals sine inverse of 27 sine 69 over 30. So I'll type this in the calculator using second sine to get the inverse. Remember to use my fraction bar. Divided by 30. And that gives me B equals 57.164 degrees. Notice that this angle is less than 69, but side B is also less than side C. So our answer does make sense. Okay. A quick word problem. A 30-foot lamppost tilts toward the sun at an 8-degree angle from the vertical. So that means this angle right here is 8 degrees. So that means this is 82 degrees. The distance between the top of the lamppost and the tip of its shadow is 34 feet. So that would be this right here. Find the length of the lamppost shadow. Okay. So now that we have that, we know that this right here is 30. So we're trying to find this measurement down here. So what we want to do is apply the law of sine to see if we can find that missing side length. In order to do that, we have to find another angle. So let's find another angle first. So we're going to label these C, B, and A. So we need to find angle A. We have to find angle A first. So we have the sine of 82 over 34 equals sine of A over 30. We're going to multiply both sides by 30. And so sine A equals 30 sine 82 over 34. We'll take the sine inverse to get A by itself. And we'll type that in the calculator. Second sine, use my fraction bar, 30 sine 82 divided by 34. And A equals 60.899. So that means this is 60.899. Therefore, this is 37.101. Using the property of a triangle, sum of all the angles is 180 degrees. So now we'll set up the law of sine for that. So sine of 37.101 over x equals the sine of 82 over 34. Now we'll cross multiply 34 sine, of 37.101 equals x sine 82 divided by sine of 82, and x equals 20.711. And there's your answer. All right. This one says sketch and solve the triangle ABC. So it doesn't really matter how you draw this. A, B, and C. A is 33 degrees. B is 105, and little b is 37.9. Well, we can easily find capital C. 33 plus 105 minus 1, subtract that from 180, and that gives me 42 degrees. So capital C is 42 degrees. Now I need to find little a and little c. So let's find little a. So we can set up our ratio. Sine of 105 over 37.9 equals sine of 33 over a. So again, cross multiply. A sine of 105 equals 37.9 sine of 33 divided by sine of 105. And little a equals 37.9 sine of 33 divided by sine of 105. 21.370. All right, next we'll find C. So sine of 42 over little c equals sine of 105 over 37.9. Same thing, cross multiply. C sine of 105, 37.9 sine of 42, divide by sine of 105. C equals 26.255. And that is the conclusion of the first half. That is all your information that you need to find when it says solve a triangle. All right, so the next thing. For angle, side, angle, and angle, angle, side, there will always be one possibility. But there is something called the ambiguous case where you can have multiple possibilities within the triangle. So if you're given a side, side angle, there will be 3 different possibilities for solving the triangle. The first possibility is when b sine of a over a is greater than 1. So looking at the diagram, this is the type of triangle that is formed when b sine of a over a is greater than 1. Notice that there is no solution because the side a is not long enough to form an actual triangle. So notice that I have here that sine of a, remember that sine is opposite over hypotenuse. So if I create a right triangle down in the middle, and I did sine of a equals a over b, then b sine of a over a would equal 1 if it was a right triangle. But since it's actually greater than 1, that would mean that this side would be too short, and it would not create an actual triangle. So therefore, when that happens, if you look at b sine of a, then and it's greater than 1, then there's no solution to the triangle. So notice what we're given here. We're given an angle A and a side A and then another side. So we're given an angle A here, side A and another side. So we're going to find b sine of A. So we'll do 5 sine of 98 over 4 and determine what that equals. That is 1.238. So there is no solution here. That's the first thing you should check. Now, when b sine of a over a is less than 1, but little a is greater than little b, there is going to be one solution because this side length is so long, it only creates one triangle. All right, so we'll do the same. We have an angle A, side A, and a B. So we'll do 2 sine of 75 over 8. And that's 0.2445. So that means we either have one solution or 2 solutions. But since A is 8 and B is 2, that means there's only one solution. For the next one, we have b sine of a over a is less than 1 also, but a is less than b. This time, notice that a is short enough to where it creates a triangle on the outside, but if you rotate this leg on the inside, it creates a smaller triangle here. So that gives you 2 separate triangles. So that means you have 2 solutions. So notice that C is your angle. So that means little c is your opposite side, and b is your other side. So you would do 9 sine of 40 over 6. Which equals 0.96. But since b is larger than c, it's 2 solutions. And notice that the side B, according to our formula, is always the adjacent side to angle A, or whatever angle you're looking at. And A is the opposite side of the angle. So in this particular problem, C represents A in our formula, and B represents B in our formula. So now that we know how many solutions to look for, we can actually solve these triangles. So for the first one, we're going to solve it using our law of sine. So we have sine of 75 over 8 equals sine of b over 2. Multiply both sides by 2. 2 sine 75 over 8 equals sine of b. So that means we'll use the inverse trig. So b equals sine inverse 2 sine 75 over 8. And that gives us b equals 13.974. So now we can find capital C by subtracting that from 180. So capital C is 91.026. So now that we know that, we can use that to find little c. So sine of 75 over 8 equals sine of 91.026 over little c. Cross multiply. Divide by sine of 75. And little c equals 8.281. And that's how you do that with the one solution. Now the next one. So now we've already identified that this one has two solutions. So we're going to create two separate triangles. All right, so the first triangle, we have our law of sine. We're going to set that up. So sine of 40 over 6 equals sine of b over 9. All right, so 9 sine 40 over 6 equals sine of b. Multiply both sides by 9. So b equals sine inverse 9 sine 40 over 6. Let's find out what that equals. And b, we're going to call this b1 because that's the first b. And that's going to give me 74.6. Now, we're going to go ahead and start the second triangle. So this is our first triangle measurement. So B2 is going to be 180 minus B1. That's you do that always. That is always the case. So 180 minus 74.6. So B2 equals 105.4. So now I'm going to find A1, capital A1. So I'm going to take 74.6, which is B1, plus 40, subtract that from 180, and I get 65.4. Now I'm going to find A2. A2 is going to be 105.4 plus 40, subtract that from 180, and that gives me 34.6. Notice that angle C from our diagram, this angle and this side stayed the same, and this side stayed the same. So your given information will be the same in both triangles. You'll just be trying to find the missing information that's different. So that's why it's okay to use A1 and B1 and C for that one triangle, A2, B2, and C for the other triangle. So now we just need to find little a1 and little a2. So we'll use our law of sine to do that. So as a sine of 40, which is C over 6, equals sine of 65.4 over a1. And then we'll go ahead and set this other one up, sine of 40 over 6 equals sine of 34.6 over a2. So we'll go ahead and solve for these. So a1 sine of 40 equals 6 sine of 65.4. Divide by sine of 40. So a1 gives me 8.487. So now we'll do the same thing for the other one. A2 sine of 40 equals 6 sine of 34.6. Divide by sine of 40. And A2 equals 5.300. So your A1 is 8.487, and your A2, little a2, is 5.300. So you have solved the ambiguous case for both triangles. Remember, whenever you start an ambiguous case problem that has two solutions, Whenever you find your first angle, always subtract it from 180 to get the same angle in the second triangle. And then you just do the law of sine to find the rest of the missing information. And that is the conclusion of the law of sines and its ambiguous case. Remember that the ambiguous case only applies to side-side angle triangles. That's when you have to check for the different possibilities.